Hi friends, in this video we would like to discuss about very important topic called mesh analysis. Mesh analysis. Okay, so I will give the concept here. Mesh is a loop. It does not consist any inner loop. It is a loop. Mesh is a loop. It does not. It does not consist any inner loop. Inner loop. Okay. So mesh analysis can be applied only for planar network, and when the network is drawn on plane without any crossover, then the network is called a planar network. So I will go with the procedure. Procedure is important. Procedure to calculate the mesh currents. The first point, identify total number of meshes or loops in the given network. In the given network. Second point, assign the current direction for each mesh or loop. Third point, develop KVL equation in each loop, in each mesh. Fourth point, by solving KVL equations, find loop currents or mesh currents. These are the four important points or procedure. So this is the procedure to find the loop currents or mesh currents in a given circuits. Let's take a small example. Okay, find mesh currents, mesh or loop currents in the given network. Okay, this is the question asked, and the circuit is given like this. There is a voltage source and one more resistor. I have a resistor, and the current source is given. This current source having the direction upward 2 amps. This is 10 ohm. This is 2 ohm. This is 1 ohm, and you can take the voltage source is 4 volt. Okay, so now you can go with the procedure. First you can find or identify how many meshes are there, how many closed loops are there. Only 2 here. So take this is 1 loop, take this is 2 loops. There are 2 loops I have. Okay, second point, assign the current direction for each mesh. So I am assigning the current direction like this, and this current I can take I1, and I am going to take another loop current. That current you can take it as a I2. I1, I2 I am assigning two current direction. You can assign any direction only. Same direction not required. You can assign your choice, that is. Okay. So I am assigning in this way. After that, I can develop the KVL equation for each loop or mesh. So apply KVL in loop 1. So I can go with the solution for this. So here you can write this is minus, this is plus. So minus 4 plus 1 into current, that is I1, and 2 ohm resistor which is common to the two loops. So you can write the you can write plus 2 into which loop current you are considering, that is first current. You can take I1 minus I2, and is there any elements present in the loop 1? No, so you can take it as a 0 now. So minus 4 plus I1 plus 2I1 minus 2I2, which is equals to 0. So I1 plus 2I1, I can write that is 3I1 minus 2I2 minus 4 equals to 0. 3I1 minus 2I2, which is equals to 4, you can take equation 1. Okay, I'm developing the KVL equation here. So now you can apply KVL in loop 2. Apply KVL in loop 2 now. So you can follow the loop direction. Okay, so as by observation, I'm not going to apply the KVL in loop direction. I can directly write the loop current, that is I2, which is equals to minus 2 amps. Why? Because minus 2 amps, that is the current direction or source current, which is opposite direction to the loop direction. Conventional direction is reverse. So I can take I2 directly, minus 2. Now you can substitute this I2. Substitute I2 in equation 1. So I can get 3I1 minus 2 into minus 2, which is equals to 4. 3I1 plus 4, which is equals to 4. So 3I1 is equals to 0. So I can write I1 equals to 0. Okay, I2 anyhow I am getting it as a minus 2 amps. If there is a voltage source, so now you can develop the KVL equation instead of 2 amps current source. Okay, keep in mind. So one more point I would like to add here. Concept of super mesh technique. Super mesh technique. Okay, when current source branch, I can write when current source branch is common for is common for two meshes. It is possible to find solution by super mesh technique. Okay, it is possible to find super mesh technique. So take a example problem here. So here take this one, a circuit having resistor and a voltage source. Again I have a common current source and there is a resistor. Again I have a 5 volts battery. This is 1 ohm and this is 2 amps. You can take this is 1 ohm and this is, you can take I1, 10 volts battery. Now there are two loops I have, so you can take loop 1. In this current you can take I1 and you can take this is loop 2, the current is I2. Okay, and by observation this is a current branch, that is 2 amps current is connected in between this one, so common current source. So by using the super mesh technique I can solve this one. So you can apply combined KVL equation. Solution: apply KVL in both loops at a time, 1 and 2 here. So minus 10 plus I1 into 1 plus I2 into 1 plus 5, which is equals to 0. So minus 10 plus I1 plus I2 plus 5 equals to 0. So I can write I1 plus I2 equals to minus 10 plus 5, that is minus 5. You can take outside, you can take it as a 5, you take as equation 1. Now we can write for this common branch current source. So what is that? That you can write directly. If you are going to consider, if you apply the KCL at this node, this current is I1, this current is I2. So if you apply the KCL at node A, you can take KCL at node A. So what will you get? Incoming currents are equals to outgoing current. So I1 plus 2, which is equals to I2. So I1 minus I2, which is equals to minus 2. Take this equation number 2. Now you can solve equation 1 and 2 and you will get the currents as, solve equation 1 and 2. I1 I am getting it as 1.5 amps and I2 I can get it as 3.5 amps. Okay, I'll stop here. Next video will continue nodal analysis and what is the super node technique.